So for our exercise 4, we will look at filters and how we can use filter to create some dynamic in a sound file, or in any sound actually, but in a sound file in particular. So for example, this is very useful for background sounds. For example, we have this file here of a cityscape, a city background, which is quite useful, for example, for a game to create an atmosphere of a city or something like that. And we could use a filter to create some dynamics in the frequency of that sound. To have some kind of evolution of the sound, some kind of organic waving of that sound, we can use a sine wave to have that frequency range going up and down. So I'm going to call this exercise 4 SineFilter. Okay. So I will import. I already downloaded the sound, so I'll import it to my exercise here. So this is a AIFF file. That means Apple Interchangeable File Format. It's basically a WAV file. It's Apple's implementation of the WAV file, similar implementation to the WAV file. So I'll just rename this, and we will do the usual operation to play back a file. So I'll create let my sound, and then I'll create a preloader that will load the sound, and I have in my clipboard I have that name of that file, and then we'll loop it. So I'm just going to say my sound set loop to true, right? And it's always a good practice to have the sound playing not by default when the application opens or when the website opens, but when you press a mouse or something like that. So I'll create a mouse function, mouse pressed, that will start the sound, right? My sound play. So let's hear it, check that it plays, check that it loops. So here we have it. It's a nice cityscape background sound, and it looped. You can kind of notice that it loops, but hopefully with the frequency modulation it will not loop as let's say as aggressively. We will soften that. So let's use a filter to change the way the sound, change that it doesn't sound more like a loop, and that it kind of creates some dynamic, some sense of movement. So let's use a filter. What are filters? So if we go to the filters, are a very important element of the sound library, and there are 3 types of filters. Filters, basically, as the name implies, they filter the sound spectrum, and they let some frequencies pass and some are eliminated. So low pass lets the low frequencies pass and eliminates the high frequencies. High pass is the opposite, lets the high frequencies pass and eliminates the low ones. The band pass creates a band in the middle of the frequency range. The band passes, but the low part to the low of that band gets attenuated, and to the high end of that band gets attenuated as well. So just the middle range passes. So let's use a band pass. So this example exemplifies how you do it. And one important part is this, the disconnect and connect aspect. So what does disconnect mean and connect? So in the filter, basically any effect that we add to a sound needs to, first, before adding any effect, we need to disconnect, to unplug the sound playing from the speakers. So the sound, instead of going directly to the output of our device, first the sound needs to be piped into or directed to the sound effect, let's say the filter, and then from the filter then it goes out. And we have kind of two important methods, which is disconnect and connect. So with disconnect, we disconnect from the output, and connect, we connect it to the filter. So that's what we need to do here in the setup. Actually, the sound set loop, I will move it to the setup just for the coherence. I'll just have the load sound there, and then all the manipulations of the sound, I'm going to do it in the output. So set loop to true, my sound disconnect, and then my sound connect to my filter. But I haven't created my filter yet, apologies for that, so I'll create it now. After my sound, let's create let my filter. So we created a filter, we disconnected the sound from the output, and we connected it to my filter. We still haven't said what the my filter is. So here, after actually before the my sound gets defined, let's define what is my filter. So my filter is a new P5 band pass. So that's, as we saw in the documentation, that's the type of filter that we are working with, right? Great. So before we use it, we need to define what is the filter frequency. So an important element of the frequency of the filter is the frequency. So in this case, in the case of a bandpass, is the frequency range that we will listen, or the frequency middle point around which the frequencies will be audible. The lower frequencies will not be audible. The high frequencies will not be audible, but the band around that frequency that we specify will be audible. I will exemplify by using the mouse as the frequency that we will map to the filter. So let's say let my frequency, for example, I'm going to abbreviate to my FREC, which is a common abbreviation, equals, I will map the mouse, for example, map mouse X, which goes from 0 to width. I will map it to a frequency range. Because we're in the middle frequencies, I'll use a range which is quite audible. So let's say between 400 and 4000. And then I will say that the my filter dot frec, so that's the method in the frequency that sets the filter frequency. So my frec, right? So this should, so recapping, so we have the usual sound playing code. We create a sound object, we load the sound, we set it to loop, we play it on mouse pressed. And then we have the code for the filter. We have the let my filter creates a filter. Then we say what type of filter it is. It's a P5 bandpass. And then we disconnect the sound from the speakers and we connect it to the filter, right? So in the draw, we map the mouse to a frequency number, and we map or we attach that frequency to the filter. So now by moving the mouse, we will change the frequency range. Let's try it out. You see, so with the mouse, by moving the mouse closer to the edge, the frequency becomes 4,000. And as it moves, here it will be around 2,000, right? And on the very edge it will be 400. So here it will be lower. We hear the lower frequencies of this sound, and we don't hear the higher ones. And here we hear the higher, not the very, very high, but this kind of mid-high range. And we don't hear the low ones. So this is quite close to the desired aspect, but what if we don't want to move our mouse to create this kind of waving of the frequency? What if we want that to be automated? That there's some kind of natural wave that goes up and down the frequency range. This could be really nice to create sounds of, I don't know, things like waves or wind or direction, some kind of natural up and down, a smooth up and down, creating some kind of dynamic in the sound. So for that we can use the sine wave, mathematical function of sine wave. If we have any growing number and we calculate the sine of that growing number, it will be always between -1 and 1 in a sine bell kind of wave, a bit like the oscillator that we saw in our earliest exercise. So we need an evolving number. So we use these kind of evolving numbers a lot, and I usually call them counters when we want to count things growing in a certain ratio. So I can say I'm going to create a counter, and in setup, the counter, I will set it to 0. That will be our initial value. Then on draw, I can say, for example, after the background value, I can say that counter increases a certain amount of units. So, for example, counter plus plus would be the same as this is the same as counter equals counter plus 1, right? I could use counter plus equals 0.1. So this would be the same, I need a semicolon up here, sorry. This would be the same as counter equals counter plus 0.1. But with sine, it's good to have very small increments. So I'm going to use 0.1 increments and see how this goes. And instead of mapping the mouse X, let's map sine of counter, and the sine always goes between -1 and 1, and let's map it to this frequency, and let's see how this sounds. Okay. So this waving is going really, really fast. If you want it to go slower, we just have a smaller increment per frame. now this waving back and forth is actually slower. So if we want to track our counter and see how fast it's going, we could print it to the console, and we use the method print counter, and we could actually visualize it growing, right? And the sign is calculated of this counter. We could actually print the sign of the counter. And this is a number going between 1 and -1, you see. As the counter grows, the sign will oscillate between -1 and 1. And we could actually draw a line to show this waving, right? We could say, instead of printing it, we could say line, or we could create a variable x to map sin counter from -1 to 1 and map it to our window, which goes from 0 to width, and then we draw a line which in the x-axis would be x, in the y-axis would be drawn from the top, which is 0, to the x point, to the point x, comma, height, from bottom to height. So this would demonstrate our filter going through the sound, right? Low, and because it's a sine wave, it has this nice curving. It's not a linear curve. It's not a triangle wave, right? It's kind of smooth in the edges. And if this waving is too artificial, we can narrow the frequency range between, now we have it between 400 and 4000. What if we have it between 2000 and 4000? You can play with these values, yeah? So now it's a more subtle waving. It creates a bit more dynamic in the sound, right? And of course, by changing the counter, we can change the waving. We could actually have it go to a higher frequency. So I've slowed it down 10 times, and I've increased the higher frequency of the bandpass. So now the filtering is slower. It creates a bit more dynamic and more organic kind of movement. Maybe it's too slow to be noticeable in time, but it's a question. It's a matter of taste. So now I can double that speed. But sometimes this kind of sine wave movements can be really useful, and we can map frequencies, we can map sound amplitudes or any parameters really to that. So it's good for background sounds, and it's generally useful to create some kind of variation upon sounds. And that's it for this example.